Okay, day 3 topic today, and this is kind of the big topic of the chapter, quite honestly. And so today we're going to talk about linear regression. And so when we are done, we want to be able to calculate a linear regression line or equation on Desmos.com and then identify, interpret the slope and the y-intercept of the equation. Okay? And so today it might be kind of hard to do this from home watching on a video because you're going to have to bounce between the video and having a web browser open. So you're going to have a couple tabs open. You're going to have one where the video's at and then one where I'm showing kind of the screens that you have. Our notes have the step-by-steps in them. So once we kind of go through it together, it's easy to kind of go back and just follow our notes on what we need to do. Okay? All right, so quick review. So remember response, explanatory. So explanatory is like our independent variable. The response is the reaction or the dependent variable. Explanatory is typically the X numbers. Response is typically the Y numbers. Okay. R, we talked about yesterday. That's that correlation coefficient. And then we talked about FODS yesterday, and that's just an acronym for when we're kind of trying to judge scatter plots, basically. So typically we talk about form, outliers, direction, and strength. Okay? And then so here's kind of a little scatter plot, and you can see I have a strong negative linear relationship with one outlier. Okay? All right, so slope. So slope, remember, what a lot of times we talk about slope when we're in linear algebra, we talk about rise over run, rise over run, rise over run. But what slope actually means is it's the amount that your line changes by whenever the x number goes up by 1. So let's say I have a slope of 5. Every one of us then knows if I said, well, what's the rise over run? All of us would say 5 over 1. I go up 5 steps for every 1 step over, okay? The problem is when we start talking about slope with fractions, like say if I said 2/3, the slope was 2/3. Every one of us probably would say my rise over run is 2 over 3. So I go up 2 over 3, up 2 over 3. But really what the 2/3 means is every 1 step I go over, I go up 2/3 of a step. Okay? And so that's something to kind of concept-wise you got to be aware of. The slope really tells me how much am I changing by each 1 step that I go to the right on. Y-intercept. So y-intercept is the value of our y number when the x number is a 0. Basically, it's the spot where the line crosses the y-axis. Okay, that's what a y-intercept is. So the value of y when x equals 0, and it's basically the spot where the line crosses the y-axis. Then we have slope-intercept form. And so last year in linear algebra, you see this a whole bunch of times, y equals mx plus b. We graph y equals mx plus b a whole bunch of times. Today with Desmos, it's going to look very similar. But notice that we have like a little 1 here instead of an equal sign. I have a little squiggle. And down here I have a little 1 by the x. And that's just kind of the way we're going to have to enter it on Desmos to get the correct answer. Okay? All right, so let's go to this page. And then at the same time, I want you to open up another web browser or another tab in your browser. And we just want to type in desmos.com, not the student Desmos that we've been doing the last few weeks. You just want regular Desmos, so be careful about that. You don't want the student version. You just want regular Desmos. I hit enter, and it gives me a screen like this. Now, if I want, I can go ahead and hit graphing calculator right away, and it'll pop up a graphing calculator. But I like to sign in because then it saves my work for me. So I'm going to sign in. Whoop, looks like we're given a bunch of new stuff. Blah, blah, blah. Sign in. Okay, so now it knows I'm there. Now I'm going to click on the graphing calculator. So go ahead and get to there. And so the problem today says find a regression line for the following points. And so they give us 1, 2, 3, 4, 5 ordered pairs. Okay? And so then it says when we are given data without the equation, we can use graphing tools to help us find a regression line that best fits the data. This topic, or this regression line, is used in real life to make predictions, so fill that in, about the future. So we collect data on things and try to watch data, and really a lot of times why we're watching that data is so we can make a prediction about something else that might happen. Okay? And then it says we are going to use the Desmos.com calculator to do this. Okay, so let's go down to the directions. So when we're in the Desmos calculator, you're going to see that little plus sign right there. You're going to hit it, and this pop-up menu is going to pop up, and we're going to want a table. So I'm going to go back to my Desmos. I'm going to hit the plus sign, and I'm going to go to table. So get that. Notice the table filled in x1, y1 up on the top. That's why we have that in our equation. And so now, let me kind of scoop my screen here a little bit. I'm going to go back up to our points. And so I need these points entered in this table. So my first point is 3, and then I'm just going to tab over to 5. So 3, 5. I hit tab and it brings me down to the next one. So 4, and then 8, 5, 9.5, 6, and 9, and 6.3, and 10. Okay? And so now if I look at my screen, I see a couple points, but I don't see all of them. Okay? And so we get our table. It says plot the data. And then it says adjust your graph to fit all the data. So if I look at my table, it looks just like the one that we did, but my graph, I can't see anything. So there's a couple ways you can do it. If you take a look at our numbers aren't very big in our table. So I'm just going to kind of move it over, and now I see my numbers. If I got a set of numbers, or I got a number that's really, really big, how you adjust that is you use this little wrench over here where it says graph settings. I click on that, and then I go down here, and it lets me pick what I want for my X and Y axis. So I personally always like to see the X and Y axis, so I always make my number a little bit negative. So I'm going to go -3, and then I just want to make sure I'm above the biggest number. So the biggest number is 10, so I'm going to go like to 15. Then on the Y's, hang on, my biggest number for X's is only 6.3, so I'm just going to go to 10 there. My Y's is where I would need to look at. So -3, and then I'm going to go 15 there. Okay, I click over here. Now I can see my data. Okay, so there's my points. They look like they're kind of in a line. And so that's good. So if you look over here, check our graph out. Now obviously here I did it a little bit different. I maybe only went up to 12. But basically same points. Okay? Next step. Enter the generic equation into Desmos. Use the squiggle for the equal sign, and y1 and x1 for the variables. So when we're done, we're going to type in y1 squiggle mx1 plus b. Instead of just regular y equals mx plus b, we're going to do that. So first thing I need to do is I got to get a place to put it. And so I'm going to click the plus sign again, and this time I'm going to click expression. So I'm going to click the plus sign, and I want an expression. And so it pops it right in. And so I'm going to hit Y, and then if I just type the number 1 right after it, it shrinks it down for me. Now you need to find the squiggle, and the squiggle is right next to the number 1 on your keyboard. So I'm going to hit Shift, squiggle, and then I just want mx plus b. So m, x, and then remember the 1 after the x. If you don't do that, it won't work, plus b. All right. So now what's great about Desmos, it draws the line right in for me. So you can see the line is kind of going through the dots. And then take a look in this box here. Once you finish it, it tells you what are called the parameters. basically our variables that we didn't know. So I get, for my slope, I get 1.29215. For my y-intercept, my b number, I get 2.02015. Okay? And so if I go back here, I enter this in. Now it says write the equation. So grab your pencil. So I'm going to write y equals, and then remember what we saw back here. I'm going to round to the hundredth, so 1.29 it looks like. X plus, and then the b number I think was 2.02, yep. And so that's our equation. And so you can see this data was what we got there. Now, one thing to point out from yesterday's lesson, that correlation coefficient. Take a look right here. It's telling us how good of a relationship we have. So we have an R value of basically 0.8957. So basically I'm going to say I'm going to go 3 spots. So 0.896. That's our correlation. So it's positive, which means our line is going up. It's somewhat close to 1, and that means our dots are close together. So if we look at our graph here, our dots are fairly close to that red line. They're not super tight. If I had a correlation coefficient like up in the 0.9 something, these dots would be super tight to that red line. But it's only 0.89, which even though it sounds like a big number, it's still, the data is starting to get spread out again a little bit. Okay? And so those are basically the steps that we need to do today. You need to be able to easily go on to Desmos and come up with an equation like this. Okay? Let's go to our next page. So I'm going to go back here. I'm going to get rid of everything. And so then we want to walk through this. Let me kind of move this over a little bit. So we want to go plus sign, table first. And now I'm just going to plug in all these numbers. And if you want, you can go up and down instead of left and right. So I'm just going to put all the X numbers in first. And the way I move down is just by hitting enter. So 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Look at that, it fills in for me already, 29. Then I'm going to go back up. Now I got to make sure I get the matching number. So I need to make sure that I have 76 match up with 18. If you start goofing it up, it messes up our data, and then we're going to have the wrong answer. And that's really usually what people do wrong, is they type a wrong number in. That's really where our mistake is going to be. The rest of the steps aren't very hard to do. All right, so I'm going to start typing in these numbers. So 76.1, 77, 78.1, 78.2, 78.8, 79.7, 79.9, 81.1, 81.2, 81.8, 82.8, and 83.5. Now make sure that you have finished at the same level as what you did the first one. Okay. All right, so I'm going to go back and read stuff here now. So it's how do children grow? The pattern of growth varies from child to child, so we can best understand the general pattern by following the average height of the number of children. The table presents the mean heights of a group of children in Kamala, an Egyptian village. Plot by hand on the graph and then do on Desmos to find the equation. Make sure to label the graph done by hand and so we need to go over here and we're going to have to do some labeling on here. And so let's go and get a marker here. So I'm going to put down here is going to be the age. And over here is going to be their height. Okay, and this is in centimeters. And this was in months. Okay. All right, first problem I notice, we have 18 to 29. So we got to count up how many spots do we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so 18 to 29 is actually going to be like 12 numbers. So I'm going to put a little break in the graph, and I'm going to start at 18 right there. Okay, so go ahead and do that. And then I'm just going to basically, each line is going to be a mark, or each line is going to be a month, I should really say. But I'm only going to go every other one. So this one would be 20, and then 22, 24, 26, and then out here is 28, and out here is 29. So we're going to be off the graph just a little bit, but only for 2 points. Over on the other graph, we got to go from 76 to 83, which actually isn't that far apart. So I'm going to do the same thing. I'm going to do a break, and then I'm going to call this first one 75, and then 77, 79, 81, 83. Okay? And so each of these points is an ordered pair that we need to get on our graph. So 18 and then 76.1, I'm going to estimate is about there. 19 is at 77. 20 is at 78.1. 22 is at, or no, 21 is at 78.2 also, or just a little bit above it. 22 is at 78.8. 23 is at 79.7. 24 is at 79.9. 25 is going to be at 81.1. So it jumps up here a little bit. 26 is going to be at 81.2, so we barely tell the difference. 27 is going to be at 81.8. And then 28 is out at 82.8. And 29 is up at 83.5. So if you need to hit pause to kind of catch up on getting the dots on there, go right ahead. But you can see, man, they're pretty much right in a straight line almost. That's a very strong relationship, okay? All right, so once you have your dots on there, now I'm going to go down and answer information. So it says find the correlation coefficient and interpret it. All right. So if we go back to Desmos, so right now, first thing I notice, I don't see any dots on there. And so basically, if you remember, I'm going to go over to this little graph setting, and then I'm going to basically mimic the graph that we just did. So we started, I'm going to start basically at a little bit under 18. So I'm going to start like at 15. And then, whoop, it went to negative 15. I want positive 15. And then we went up to 29. So I'm going to go a little bit past that. I'm going to go like to 33. Okay. And we're going to step by one. We're going to count by ones. Whoop, I'm taking that off. I didn't like that. Too much stuff on the graph. Then the y-axis, we started at 75, and I'm going to say like 85. And so now if I click over here, here's my graph basically, okay? So those are the same dots we just saw. I can close this back up a little bit if I want, but now it's hard to see my x and y axis, so I like to get that on there. And so you can see the little labels here on the side, okay? So now if you remember, so we have to get that equation. So I'm going to hit plus expression, and then I'm just doing y equals mx plus b, but remember it's y1, and then I do the squiggle, mx1 plus b. And now the reason I do x1 and y1 is because that's what my table of values is. Sometimes these table of values will switch numbers, and maybe it'll pop up sometime where it says x2 or y2. Well, then I would have to change my equation, okay? All right, so R value 0.9944. So I'm going to go in here, and I'm going to write that in there. So 0.9944. So go ahead and put that in. Make sure that you've done all the steps on Desmos for yourself. And then it says to interpret that. What does that mean by interpreting it? And so if you think about what we talked about yesterday, and so interpreting that thing, 0.99, that's almost 1. And so when it says to interpret it, what we would say is there is a strong positive, because it's a positive 0.99, relationship between age, I'm going to put in months, and height. And then that we measured in centimeters. So basically I'm kind of taking a line out of that FODS sentence that we did yesterday and describing the correlation. Okay. Now it says find the regression line. Okay, so if I go back to this, so our regression line, right there are important numbers. And so this one I'm going to use 0.63. This one I'm going to use 64.93 for my numbers. Okay? And so that's what I'm going to put onto here. And so regression line, y equals 0.63x plus 64.93. Okay? Then it says to interpret the slope. Okay? So the slope is this 0.63. And so back in the beginning of today's lesson, I said the slope represents the change in the y value for every one step in the x value. Okay, so here's what this means. X is our months. And so this 0.63 means, and y is our height. And so what this 0.63 means is every 1 month I go up in age, my height should go up 0.63 centimeters. Okay, and so that's what that means when it says interpret the slope. So here's what we're going to write. For every month increase, there is a 0.63 centimeter increase in height. Okay, so every month I get older, my height goes up by 0.63 centimeters. That's what the slope in this scenario truly means. Okay, so for every trying to clean this up a little bit. For every month that I get older, my height goes up by 0.63 centimeters. Okay. Now, one thing to be aware of with this data, every regression line only is as good as its data and the time frame that its data is good for. So basically between 18 and 29 months is where the 0.63 is kind of in its sweet spot. Now, when we get to our age, there's no way we're growing by 0.63 centimeters every month. We'd keep growing and growing and growing. It would be huge, okay? This is more for like toddler age. Think 18 to 29 months. That's right around when you turn 2 years old, okay? All right, interpret the y-intercept. So the y-intercept is the value of y when x is 0. So x is our age. and y is our height. And so 64.93, that basically means when we're born, the average height or length of a baby is 64.93 centimeters, not inches, remember centimeters, okay? And so at birth, that means when our age is 0, the average height was 64.93 centimeters, and you could round that if you wanted to 65 centimeters basically. Okay? So that's what that means. And so we need to be, that's a big thing, and we have to be able to interpret what do these things mean in terms of our problem. What does the slope mean in terms of our problem? And that's what we're changing by. The slope is always saying what we're changing by. And then the y-intercept is always our starting point. Okay? Then this is a big thing. So this is where we use these equations. Now we want to make predictions. And so now we have this equation that correlates our height and our age. Okay? And so it says predict the height at 32 months of age. So I'm going to copy down the equation again. And so age was the x number. So I need to take that 32 and put it in for the x number. And so this is our note, so make sure you do a little bit more detail. Don't just copy down my final answer. Let's put in what are we literally doing with these numbers. So I'm going to rewrite that equation, and where I saw the x number, I'm going to plug in 32. Okay? So now if I go grab my calculator, 0.63 times 32, I think gives me 20.16. And then I got to add on the 64.93. And so my y value is 85.09, or essentially 85 centimeters. So in theory, the average height of a kid at 32 centimeters, or 32 months, should be 85 centimeters in this village that we're talking about. Okay, then we can use the opposite. We can predict how old will somebody be when they hit 100. So this is now the height, so that means that's the y value. So same thing, just because this is our notes, I'm going to write a little bit more detail. And so I'm going to put 100 in over here. 0.63x plus 64.93. I'm going to subtract, kind of think of your linear algebra skills. I'm going to subtract the 64.93. And so we're going to get 35.07 over here and 0.63x over here. Remember, these two cancel out, that's why we're doing it. Now I want to get the 0.63 away from the x, so I'm going to divide by 0.63. And so I get 55.67, which is approximately, if I round it to the whole month, 56 months. So that's basically over 4.5 years old. That's when they would hit 100 centimeters. And so think 100 centimeters is like a yardstick, or a little bit bigger than a yardstick. Think like a meter stick. So it's a little bit over 3 feet tall. Okay? All right. Make sure that you can do this on Desmos, and make sure that you have the ability to kind of go back and forth with these equations. This page right here, kind of everything we did on this page, this is kind of the big stuff you need to be able to do when we get to test time. You got to be able to find the correlation coefficient and understand whether it's telling us if it's a good relationship or not, or association or not. We got to be able to find the regression line. We got to be able to interpret what slope means. We got to be able to interpret the y-intercept. And then we have to be able to use our equation to make predictions about the future. Okay? So just be aware that we got to have all those skills. If you need to go back and watch the video again, go right ahead and do that.